billions of years before the first human drew breath. The universe was already writing a story without an author. Violent collisions. Cosmic dust settling into a sphere of molten rock. A world born of fire and chaos. And somehow, through an impossible sequence of events, a single, sterile planet was destined to become the cradle of consciousness. But there's a chapter of this Genesis most people never read, because the version we know is just a highlight reel. The full story. Earth's history is not a gentle slope, it's a battlefield. A series of near misses and catastrophic resets. With our existence hanging by a thread. And tonight, we pull back the curtain on deep time, frame by frame. Our journey begins not with life, but with the stage it would perform on. 4.5 billion years ago, Earth was a hellscape, an ocean of magma under a toxic sky, bombarded by asteroids left over from the solar system's chaotic birth. There was no water, no air, no hope. Then a cataclysm that should have destroyed everything instead became the ultimate act of creation. A Mars-sized planet named Theia slammed into our young world. The impact was apocalyptic, vaporizing rock and tilting our planet on its axis. But from that ring of ejected debris, a partner was born. The moon, its gravitational pull, would stabilize Earth's wobble, creating the predictable seasons and tides that life would one day depend on. It was the first and perhaps most critical "wait what" moment in our planet's history. A cosmic accident that gave us night and day and a steady rhythm for the symphony of life to come. For hundreds of millions of years, the planet cooled, volcanoes spewed gases, forming a primitive atmosphere. Comets and asteroids, once agents of destruction, now became bearers of a precious gift: ice. They peppered the earth, delivering the water that would form the first oceans. It's here in this primordial global ocean, around 4 billion years ago, that the impossible happened. In volcanic vents deep beneath the waves, where heat and chemicals churned in a high-pressure abyss, something stirred. Non-life became life. We don't know exactly how. Perhaps a lightning strike, a chance chemical reaction, or a gift from a meteorite. But simple organic molecules linked together formed a protective membrane and created the first living cell. A single, microscopic organism, the last universal common ancestor. You, me, every plant, every animal, every fungus on this planet. We all share a direct line to this one microscopic spark in a dark ancient sea. For the next billion years, that was it. A planet teeming with invisible single-celled life. They were simple bacteria and archaea, floating, replicating, and dying. To a visitor, Earth would have looked utterly barren, but beneath the surface, a slow-motion revolution was underway. One of these organisms developed a new trick, a hack. It was called photosynthesis. Using energy from the young sun, it began to breathe in carbon dioxide and exhale a new, potent and highly toxic gas, oxygen. This event, the Great Oxidation Event, was the planet's first mass extinction. Oxygen, the very gas we depend on, was poison to most life on Earth at the time. It rusted the iron out of the oceans, turning them from a murky green to a clear blue. It wiped out countless anaerobic species, but for the survivors, it unlocked a powerful new energy source. A world of incredible complexity was now possible. This new, oxygen-rich world set the stage for the next great leap. Around 2 billion years ago, one cell did something unprecedented. Instead of competing with another cell, it engulfed it, but it didn't digest it. The two cells formed a partnership, a symbiosis. The smaller cell became a dedicated power plant, the mitochondrion, and the larger cell provided protection and resources. This was the birth of the eukaryotic cell, the complex cell type that builds every animal and plant today. It was a merger, not a mutation, that laid the foundation for us. For another billion years, these new, more complex cells remained single. But then they started to stick together, forming colonies, specializing, some cells for movement, some for feeding, some for reproduction. They were inventing the blueprint for a body. Then, 540 million years ago, the fuse was lit. In a geological blink of an eye. Life exploded in a frenzy of creativity known as the Cambrian explosion. Skeletons, shells, eyes, and claws appeared as if from nowhere. The oceans, once home to little more than microbial mats and soft-bodied oddities, were suddenly filled with creatures that seem ripped from science fiction. Trilobites with crystal eyes scuttled on the seafloor. Anomalocaris, a 2-meter-long predator, hunted with formidable grasping appendages. It was an evolutionary arms race, a riot of experimentation where the basic body plans of nearly all modern animals were forged. This wasn't a slow, gradual process. This was a wait what moment of biological insanity. In this frenzy, a tiny worm-like creature appeared. It had no fins, no jaws, and no bones. But it had one revolutionary feature, a primitive spinal cord called a notochord. It was one of the first vertebrates. It was our ancestor. Life moved onto land. First plants, then insects, then amphibians crawling out of the water. This led to the age of reptiles, and eventually the dinosaurs. For 150 million years, they were the undisputed masters of the planet. During their reign, our own ancestors were tiny, shrew-like mammals. They were insignificant, living in the shadows, scurrying under the feet of giants. Their survival strategy was simple: stay small, stay hidden, and come out at night. For millions of generations, this was their world. A world where they were not the heroes of the story, but minor, supporting characters seemingly destined for obscurity. Their future, our future, was capped by a ceiling of reptilian dominance. And then, 66 million years ago, the sky fell. A 6-mile-wide asteroid, traveling 30 times the speed of a rifle bullet, struck the coast of modern-day Mexico. The impact unleashed the energy of 1 billion atomic bombs. It triggered global earthquakes, volcanic eruptions, and a colossal tsunami. A plume of superheated dust and ash blanketed the globe, blocking out the sun and plunging the world into a dark, freezing winter that lasted for years. The dinosaurs, the titans of the earth, starved and froze to death. 75% of all species on the planet vanished. It was an extinction that erased an entire era. But down in their burrows, our small warm-blooded ancestors held on. They survived the cold, feeding on insects and seeds in the world of ash. The death of the dinosaurs was the single most important event for our lineage since the invention of the cell. The giants were gone, and for the first time in 150 million years, the world was open for business. In the wake of the apocalypse, mammals exploded. They diversified, filling every vacant niche. They grew larger, smarter, and more varied. Some returned to the sea, becoming whales. Others took to the air, becoming bats. And one group took to the trees. These were the first primates. Living in the canopies of the new, sprawling jungles, they developed grasping hands and feet to navigate the branches. Their eyes, once on the sides of their heads, moved to the front, giving them binocular three-dimensional vision essential for leaping from branch to branch. Their brains grew larger to process this complex visual information and to navigate the intricate social politics of a primate troop. They were fast, agile, and intelligent. For millions of years, they thrived in the trees, a dynasty of apes and monkeys spreading across Africa and Asia. But the world never stops changing. Africa, once a blanket of lush rainforest, began to dry out. The jungles receded, replaced by vast open grasslands, the savanna. For the primates who lived there, this was a crisis. Their treetop highway was gone. To survive, they had to descend to the ground, a dangerous new world filled with predators. Most lineages stayed with the shrinking forests. But one group, around 7 million years ago, did something radical. It committed to the ground. This single decision, forced by a changing climate, was the final what moment. A fork in the road of evolution. One path would lead to the chimpanzees and bonobos, who remained partially tied to the trees. The other, that path was ours. Here on the dusty floor of the African savanna 7 million years ago is where the human story truly begins. The moment we split from the apes and stood on our own 2 feet, the first step on a journey that no one could have predicted. The story of that journey begins now. 7 million years before the first city was built, before the first fire was tamed, a single branch on the great tree of life began to split. It was a separation so subtle, so quiet, it went unnoticed by the ancient world. On one path, the ancestors of modern chimpanzees continued their journey. On the other, a new lineage began, one that would stumble through the darkness for millennia, guided by chance and necessity. This is not the story of a triumphant march toward destiny. This is a story of survival, a story of the first tentative steps away from the forest and into a world of unknown dangers, a world that would forge the first of our ancestors. Our story begins not with a king or a conqueror, but with a fossil, a collection of bones pulled from the dry earth of Africa, the cradle of all humanity. These bones speak of a creature that was neither ape nor human, but something in between, a ghost from a time when our own family tree was just a sapling. We call them Australopithecus, the southern apes. For nearly 4 million years, they were the protagonists of the human story, a sprawling family of different species, each adapted to a unique corner of the ancient African continent. Their world was not the one we know. It was a mosaic of dense woodlands giving way to open savannas, a landscape teeming with predators far larger and faster than them. The most profound change, the one that truly set them on our path, was not in their brains, but in their feet. Fossilized footprints preserved in volcanic ash at Lotoli, Tanzania, give us a ghostly snapshot from 3.6 million years ago. A family, perhaps an adult and a child walking side by side. Their tracks are hauntingly familiar. They show a creature that walked upright on two legs. This was bipedalism. It was not a choice. It was a revolution born of necessity. As the climate of Africa grew drier, the vast forests began to shrink, replaced by grasslands. Walking on two legs was brutally efficient. It freed the hands to carry food, to hold infants, to perhaps one day grasp a tool. It allowed them to see over the tall grass, to spot danger, and to find opportunity. But do not picture a graceful, striding human, the skeleton of one of the most famous fossils ever discovered. A female Australopithecus afarensis, nicknamed Lucy, tells a more complicated story. Her pelvis and leg bones are unquestionably built for walking upright, yet her long, curved fingers and upward-pointing shoulder joints are echoes of her tree-dwelling past. She was a creature of two worlds, walking the plains by day, but likely scrambling into the safety of the trees at night to escape the saber-toothed cats and giant hyenas that hunted in the darkness. She lived a life of constant negotiation between the ground and the canopy, a bridge between two entirely different ways of being. What did they eat? For a long time, we imagined them as mighty hunters. The truth, etched into the microscopic scratches on their fossilized teeth, is far more humble. Their powerful jaws and large molars were grinding machines built to process tough fibrous plants, roots, tubers, and the occasional fruit. They were primarily foragers, opportunists. Analysis of their tooth enamel reveals a diet that shifted with the seasons, a testament to their adaptability. They may have scavenged meat when they could, stealing scraps from the kills of more capable predators, but they were not the apex of their food chain. They were simply survivors, taking what the unforgiving landscape would give them. And they were not alone. We often imagine evolution as a single, linear progression, one species neatly replacing another. The fossil record proves this is a myth. For hundreds of thousands of years, multiple species of Australopithecus coexisted. There were the gracile forms, like Lucy's species, Afarensis, and its probable descendant, Africanus, But alongside them lived the robust Australopithecines, a side branch of our family tree with enormous chewing muscles, massive jaws, and a bony crest on their skulls to anchor it all. These were specialists, hyper-adapted to a diet of the toughest, grittiest vegetation imaginable. They were a successful experiment in their own right, but ultimately they were an evolutionary dead end. Their specialization, once a strength, became a fatal weakness when the climate shifted again. They vanished, leaving only their powerful bones to tell their tale. Did they speak? Did they have culture? This is where the evidence turns to silence. Their brains were only slightly larger than a modern chimpanzee's, the cerebral leap still millions of years in the future. Their social structure was likely similar to that of modern primates, small, close-knit groups, bound by kinship and a constant shared struggle for survival. They lived, they foraged, they raised their young, and they died, all without leaving behind a single intentionally crafted tool, a single piece of art, a single symbol of abstract thought. They were intelligent animals, no doubt masters of their environment. But the spark of what we call humanity had not yet been kindled. They were the essential foundation, the long and arduous preface to our story. For millions of years, this was the state of our lineage. A bipedal ape, clever and resilient, spreading across the African continent, diversifying into new forms, and then, just as quietly, fading into extinction. They were a crucial chapter, the link that proves our deep connection to the natural world. They took the ape body plan and, through the immense pressure of a changing world, warped it into something new. They stood up, and in doing so, they set the stage for everything that was to come. They were the quiet pioneers, the first to walk the path that would, through countless more trials and dead ends, lead to us. But in the dust of East Africa, around 2.5 million years ago, another set of fossils begins to appear. Something different. Something with a larger brain case. And lying next to these bones, for the first time in the history of our planet, are stones. Stones that have been deliberately broken and shaped. They are crude, simple choppers and flakes, but they are not the work of nature. They are the work of a mind that could see a tool inside a rock. This was not just another adaptation. This was the dawn of technology. The Australopithecine chapter was closing, and a new, more dangerous, more promising creature was about to take the stage. The age of the handyman was beginning, and with it, the next great leap in the human maze. For countless generations, survival was a game of chance, a brutal equation written in tooth and claw, where the strong, the fast, and the lucky inherited the earth. The weak simply vanished, their stories dissolving into the African dust. But in the long shadow of the Great Rift Valley, something was stirring. A new force was about to enter the game, one that would rewrite the rules of existence forever. The version we know is just a fragment, a whisper from a forgotten age. The truth. The dawn of humanity was not a single sunrise. It was a storm, a chaotic symphony of false starts and dead ends. played out across a landscape of constant change. And tonight, we witness the moment the first note was struck. The stage for this revolution was set 2.5 million years ago. The world was cooling. The dense forests of our Australopithecine ancestors were retreating, giving way to vast open savannas. For a small, unassuming hominin, this new world was a death sentence and an opportunity all at once. Out on the plains, they were exposed, slow, and hopelessly outmatched. They couldn't outrun the saber-toothed cats or outmuscle the giant hyenas. By all the laws of nature that had governed life for billions of years, they should have been a footnote in the fossil record, a failed experiment. But they possessed something new, something bubbling just beneath the surface of their primitive minds. This creature was Homo habilis, the handy man, shorter than us, with long arms that still spoke of a life spent in the trees. They were a mosaic of old and new. Yet look closer and you see the future taking shape. Their faces were less projecting, their teeth smaller, and most importantly, their brains were undergoing a dramatic expansion. While their Australopithecine cousins had brains around 450 cubic centimeters, Homo habilis boasted an average of 600. This wasn't just more of the same, it was a fundamental rewiring. The regions of the brain associated with planning, problem-solving, and fine motor control were beginning to connect in novel ways. A silent biological arms race was unfolding not in the body, but in the mind. Inside this expanding skull, a revolutionary idea was born, an idea that would alter our planet more than any single event since the asteroid that wiped out the dinosaurs. It wasn't an idea about gods or art or love. It was simpler. It was the profound realization that the world could be reshaped, that a rock was not just a rock, held in a specific way, struck against another with precise force and a clear intention. It could become an extension of the will. It could become a tool. At sites like Lamikvi in Kenya and Olduvai Gorge in Tanzania, the evidence lies scattered like broken promises. These are the Oldowan tools, the oldest stone technology in human history. To our modern eyes, they look crude, barely distinguishable from naturally fractured rocks. But to dismiss them is to miss the miracle. Each one represents a complex sequence of thought. First, the selection of the right raw material stone that would fracture predictably. Then, the visualization of the finished product, sharp edge, a chopper. Finally, the executioner series of controlled, forceful strikes angled perfectly to shear off a flake. This wasn't instinct. This was foresight. This was engineering in its most nascent form. Imagine a small band of Homo habilis, huddled together as dusk falls over the savannah. They are scavengers, living on the margins. They follow the great herds, waiting for the predators to make their kill. Before, they would have been limited to whatever scraps of meat they could tear away with their bare hands and teeth. But now they have an advantage. Armed with their razor-sharp flakes, they can slice through tough hides that even a lion's teeth would struggle with. With their heavy choppers, they can smash open long bones to get at the prize within, the rich, calorie-dense marrow. This was the key. Marrow and brain tissue are packed with the exact fats and proteins needed to fuel a hungry, growing brain. Technology had created a powerful feedback loop. Better tools led to better nutrition. Better nutrition fueled a larger, more complex brain. And a larger brain could conceive of and create even more sophisticated tools. For the first time in the history of life on Earth, a species had found a way to bypass the slow, grinding pace of biological evolution. We were no longer waiting for nature to grant us sharper teeth or stronger claws. We were making our own. Natural selection was no longer acting just on our bodies. It was now acting on our culture, on our ideas. The hominin who could learn to make a better tool or teach that skill to their offspring had a greater chance of survival. Intelligence itself had become the primary trait for success. This wasn't just about food. It was about seeing the world differently. Homo habilis walking across the landscape no longer saw just rocks, trees, and animals. They saw resources. They saw potential. That smooth, water-worn cobble held the promise of a sharp edge. That distant herd of antelope was not just a threat, but a future meal. The mind was now actively mapping, planning, and exploiting the environment. The link between hand, eye, and brain was forged in these moments, creating a template for everything that was to come from the first stone chopper to the microchip. This shift was permanent. It was irreversible. We had stepped onto a new evolutionary path, one where technology and biology were forever intertwined. Each generation would now inherit not just a set of genes, but a growing body of knowledge. A culture, the ability to learn, to imitate, and to innovate became more important than brute strength. We had outsourced our evolution, trading the power of muscle for the power of mind. The process was slow, almost imperceptible, unfolding over hundreds of thousands of years. But the die was cast. The future belonged to the thinkers, the makers, the problem solvers. For nearly 1,000,000 years, the handyman and their simple stone tools dominated the African landscape. They were a success story, a testament to the power of a single, brilliant idea. They laid the foundation upon which all future human achievement would be built. But evolution never stands still. The climate continued to change, new pressures emerged, and the feedback loop of brain and tool kept spinning faster and faster. Within the Homo habilis population, another transformation was already underway. A taller, stronger, and even bigger-brained hominin was beginning to appear in the fossil record.